The warning signs have been there for some time now. Persistent failures of the wheat crop in Norway, for example. The North Atlantic is cooling. The cooling trend was evident at the time of an expedition to investigate this phenomenon 3 years ago. The rate of cooling has now steepened up since then based on the latest data collated by Professor Humlum of the University of Oslo. From that data set, this graph shows the heat loss since 2004 for the top 700 meters of the water column. As Figure 1 show, North Atlantic heat content peaked in 2004. The decline since the peak has been steeper than the rise. What would be the reason for 2004 being the peak year? Part of the answer may be that 2004 was the second peak of solar cycle 23, with a big increase in the proton flux. Another part of the answer may be that there was a big fall in the AP index in 2005 down to solar minimum-like levels, followed a couple of years later by a discontinuity as the level fell through the floor of the established minimum level of activity. That is shown in this graph. We might not care too much about the animals that live in the North Atlantic water column, but the temperature of the surface is the main control on the climate of Europe. So what has that been doing? As Figure 3 from Professor Humlum's work shows, summer heating is penetrating to half the depth it used to 10 years ago, and in winter earlier this year sub-8 seawater was at the surface for the first time in more than 10 years. That cooling trend is quantified in the following graph. This is data from the main part of the North Atlantic current. The average temperature has fallen 1.0 C from 2006 to 2016. That is a trend of 1.0 C per decade, but with 60% of the cooling in the last 2 years. Europe's climate has responded with snow down to 2,000 meters in August in Germany this year. And how much lower can the North Atlantic temperature go? The lowest point on Figure 1 was in 1973, during the 1970s cooling period, and corresponds to a fall of a further 1.5 C at the decadal trend since 2016. We would get there in 2031. At the trend of the last 2 years, we would get there in 2021. That is supported by what is happening to solar activity. Over those last 2 years, the F10.7 flux has been in a steep downtrend. Figure 5 shows that the F10.7 flux is in a steep quarterly downtrend that will take it to the immutable floor of 64, about 3 years before solar minimum is due. After that comes solar cycle 25. Back in 2003, S-Team solar physicists Ken Shadden and Kent Tabiska warned that the surprising result of these long-range predictions is a rapid decline in solar activity, starting with cycle 24. If this trend continues, we may see the sun heading towards a Maunder type of solar activity minimum, an extensive period of reduced levels of solar activity. They got the decline of solar cycle 24 right, and the North Atlantic cooled in response. If they get the Maunder part of their prediction correct too, then it will be some years before North Atlantic cooling bottoms out. This has nothing to do with human impact on climate change, but more so the activity of the sun, and how solar cycles impact our climate as well. It's based on a mathematical model that shows the sun might quiet down in the coming years, thus impacting our climate as well. This is not a climate change denial article. Please read it before commenting. A few months ago, NASA published a study showing that Antarctica is actually gaining more ice than it is losing. They made the announcement after using satellites to examine the heights of the region's ice sheet. The findings contradict the prevailing theory that Antarctica has actually been shrinking. However, the paper is titled "Mass Gains of the Antarctic Ice Sheet Exceed Losses" and was published in the Journal of Glaciology. The authors of this study are from NASA's Goddard Space Flight Center, and the cause of this ice gain isn't entirely known, but a number of theories are mentioned in the paper. It is worth mentioning, however, that NASA was blasted by dozens of their own scientists regarding their global warming stance, even though a number of the world's top scientists have questioned just how much an impact greenhouse gases have on climate change. Perhaps there are other factors contributing to climate change. Just a few years ago, Antarctic ice extent had reached an all-time high. There are many theories as to why this is so, and one of them includes the effects of supposed global warming, but not everyone agrees. That's a completely separate topic, however, and you can learn more about it in the articles linked at the end of this article. When it comes to climate change, a lot of emphasis is put on human activity, and rightfully so, as our ways here need to change. Perhaps in our fervor to discover our own culpability in this shift, However, we missed a few things along the way. What about the natural cycles of climate change Earth experiences, and has experienced? It's a scientific fact that fluctuations in the solar cycle impact Earth's global temperature, as do other massive bodies flying in and around our solar system. The most recent research to examine this topic comes from the National Astronomy Meeting in Wales, where Valentina Zarkova, a mathematics professor from Northumbria University, UK, presented a model that can predict what solar cycles will look like far more accurately than was previously possible. She states that the model can predict their influence with an accuracy of 97%, and says it is showing that Earth is heading for a mini ice age in approximately 15 years. According to the Royal Astronomical Society (RAS), a new model of the Sun's solar cycle is producing unprecedentedly accurate predictions of irregularities within the Sun's 11-year heartbeat. The model draws on dynamo effects in two layers of the Sun, one close to the surface and one deep within its convection zone. Predictions from the model suggest that solar activity will fall by 60% during the 2030s to conditions last seen during the mini ice age that began in 1645. Zarkova and her team came up with a model using a method called principal component analysis of the magnetic field observations from the Wilcox Solar Observatory in California. Looking forward to the next few solar cycles, her model predicts that from 2030 to 2040 there will be cause for a significant reduction in solar activity, which again will lead to a mini ice age. According to Zarkova, in cycle 26, the two waves exactly mirror each other, peaking at the same time, but in opposite hemispheres of the Sun day their interaction will be disruptive, or they will nearly cancel each other. We predict that this will lead to the properties of a Maunder minimum. Effectively, when the waves are approximately in phase, they can show strong interaction, or resonance, and we have strong solar activity. When they are out of phase, we have solar minimums. When there is full phase separation, we have the conditions last seen during the Maunder minimum, 370 years ago. Pretty interesting to think about it, isn't it? With so much attention being paid to the warming of our planet, it would be quite a shocker to suddenly enter into an ice age. Again, this has nothing to do with human impact on climate change, more so the activity of the Sun, and how solar cycles impact our climate as well. This is not a climate change denial article. It's basically bringing up the fact that there are more factors to consider that play a role in climate change. What are your thoughts?